Welcome back, ladies and gentlemen. So today we are going to be wrapping up Cycle 3 by looking at possibly the most important lesson, or certainly one of the most important lessons we're going to learn all year, and that is different ways we can find the equation of a line given various little bits of information. This is really what we've been building towards. Ever since we started getting into anything about the line, this is one of the major aspects of this course that we want you to carry forward. So, what do we need to remember? For the equation of the line, ultimately there are two things we need to remember. There are two pieces of information we need. We need to figure out m, and we need to figure out b. Remember that m is your slope of the line, and b is your y-intercept. Ultimately, that is every question that I'm going to be giving you. What is the slope? What is the y-intercept? Once we have those two pieces of information, we have the equation of the line, and we can just write them into the equation y equals mx plus b. So while we're working through these problems, some of them start looking rather confusing and a little esoteric in the information that you're given, but what it all comes down to is, how do I find slope? How do I find y-intercept? So I want you to remember that moving forward. Let's start with one of the easier examples. And what if I actually gave you the graph of a line? So over here, you can see I have 5 different lines on my grid, and we're going to find the equations for all 5 of them here. We'll start with A, and that's the line that I have in red. So again, our plan of attack, we need to find the slope, and we need to find the y-intercept. So how do we find the slope given a graph? Well, going back to one of the first methods we have is we know our slope. When you have a graph, we could think of it as rise over run. So what we can do is we can pick any 2 points on our graph. Try to pick points that seem to line up nicely. So I'm going to pick this point here, and it looks like maybe this point right here. And if I draw my triangle like that, we can see we're going over 1 and up 2. So my rise is 2 and my run is 1. So that gives me a slope of 2. So for question A, I know my slope is 2. So y is going to be equal to 2x plus something. That something, remember, is the b value. That's our y-intercept. When you have a graph, it's really easy to find the y-intercept because we can just read it right off the graph. We can see my y-intercept appears to be right here at -4. So for graph number A, we have y equals 2x minus 4. Clean that up a little bit. Let's go ahead and look at graph number B now. I keep saying number B, letter B. Again, we can pick any 2 points that work. It looks like right here at the origin, that appears to be a point. And let's pick a point, say, way down here. And I can draw my triangle in. And we can see we're going over 2 and down 6. So 2 and 6, that would give me a slope of 3, but notice the graph is going down and to the right, so our slope is actually going to be negative, so this gives us a slope of -3. So y equals -3x, and then again we can look for our y-intercept. Well, in this case the y-intercept is the origin itself, so that would be 0, which means I don't need to write anything. The b value is 0, so the equation is simply y equals -3x. C. All right, C up here at the top we can see is a horizontal line. Now that was one of the special cases from yesterday, and if we're looking at our horizontal line, what would the slope be? Well, again, we can do the same thing. We can pick any 2 points that we want. So let's look at this point here. This point appears to be 9, 0, and we can look at, say, this point here, which is at not 9, 0, excuse me. That would be at 0, 9. And this point would be at 4, 9. So our rise is 0, and our run, you can see I'm going over 4 units. So I'm going up 0 and over 4, so that's a slope of 0. So y would be equal to 0x. I don't need to write anything there. And it's just the y-intercept now that I need, which is 9. So my equation is y equals 9. And we talked about this yesterday, the fact that any point that I write on here, we can see this point over here is -5, 9. Notice what they have in common. They all have a y coordinate of 9 every single point. So we just say, well, y equals 9. Let's look at D now. So for D, this is a little bit more like the first two that we looked at. So again, I'm going to choose 2 points. This appears to be a nice point here, and this one right here. So for this one, I'm going over 6 and down 2. So my rise is -2 and my run is 6. So -2 over 6, we should reduce that fraction. So that is -1/3, and there's my slope. So y is -1/3 x plus our y-intercept, which I can read off my graph, is 3. So the equation of that line, y equals -1/3 x plus 3. All right, lastly, over to E. E, we can see, is a vertical line. Now again, a vertical line was one of those special cases from yesterday. Very difficult to find the slope. If you try to find the slope of a vertical line, you're going to end up dividing by 0. I'd invite you to go back and look at the last lesson to get a fuller explanation of that if you don't recall. But with this case, we can follow some of the same logic. If I look at this point here, this is -9, -6. Over here, I have -9, -2. If I go up here, I have -9, +3. What do they all have in common? They all have an x-coordinate of -9. So I just say, well, this is x equals -9, and that's the equation of a vertical line. All right, so that's what we can do if we have the actual graph. What if we don't have a graph? Now I'm just going to give you various bits of information, and our job is going to be to figure out what is the equation of the line. But again, ultimately, what are we after? I know the equation of my line is y equals mx plus b. So as we're going through these, I want you to ask yourself, what is m, what is b? As long as we have those two bits of information, we can get our equation of the line. So in this case, they're telling us we have a slope of 3 and we have a y-intercept of 6. Well, those are the two pieces of information I want. Here's m, here's b. So when they give you the slope and the y-intercept, we can just write that out. So that means y equals 3x plus 6. And that's it. That question's a bit of a gimme. How about this one? For this one, they've given us the slope again. However, now they've just given us some random point, 3, 7, that's also on the line. So we have our m, but we don't have our b. So I can fill this out so far. I know y equals -4x plus b. So now the question becomes, well, how do I figure out what that b value is? Well, obviously I must have given you this point for a reason. Remember what a point is. We always write a point as x, y. So what I've given you here are xy coordinates, and those xy values I can plug in my equation. So we can see my x value is 3 and my y value is 7. So if y is 7, that's going to be equal to -4 times x, which is 3, plus b. Well, now if we look at this, this is just an algebraic expression, and we've looked at how to solve for those algebraic expressions in the past. We can just solve for b. So 7 is going to be equal to -12 plus b. I will add 12 to both sides, and I can see that b is going to be 19. Now, so often, students will do all this work, they'll get all the numbers they need, and they'll stop. But you haven't answered the question yet. Remember, I'm looking for the equation of the line. So over here, therefore, y equals negative 4x plus 19. And there's our equation of the line. Do not forget to actually answer the question and give us the equation. Let's try another one. All right, in this case now, I'm just giving you two different points. Okay, so again, we know what we're looking for. Y equals mx plus b. Well, let's start with the slope. Do we have a way to find the slope of a line given 2 points? And the answer to that is yes. We have a slope formula that we learned last cycle. We know m is delta y over delta x. Or another way of saying that is y2 minus y1 over x2 minus x1. If you recall, it doesn't matter what you call point 1 and what you call point 2. I'll call 2, 6 point 1 because it comes first. So that would mean this is x1 and this is y1. This would be x2 and this would be y2. So based on this, we have negative 6 minus 6 over negative 1 minus 2. So negative 6 minus 6 is negative 12 over negative 1 minus 2 is negative 3. Negative 12 divided by negative 3 is positive 4. And there's our slope. So now we know y is equal to 4x plus b. We still don't know what the b is. So how do we find b? Well, we can solve for b in the exact same way we solved for it in the previous example. All we need to do is take one of the points and plug it in for our x, y coordinates. Now, which point should you use? We have point 1 and point 2. The short answer is it doesn't matter. Either one you plug in will give you the same answer. And just to show that, in fact, I'll do both. Let's start by plugging in the 0.26. So our y value is 6, and that's equal to 4 times the x value, which is 2, plus b. So 6 is equal to 8 plus b, so b must be negative 2. What if I had plugged in my other point instead? Let's just try that real quick. So if I were to choose 0.2 over here, my y value is negative 6. That would be equal to 4 times negative 1 plus b. So negative 6 is equal to negative 4 plus b. I'm going to have to add 4 to both sides. And we can see b is equal to negative 2. So it doesn't matter which point you plug in because you're going to end up with the same answer no matter what. B is negative 2. Again, don't forget to actually answer your question now. So therefore, y is equal to 4x minus 2. And there's your equation of the line. What if I gave you a table of values? Well, given yourself a table of values, it's exactly like the previous question. In the previous question, I gave you 2 different points. Now, I've given you 5 different points. Which point should you choose? Again, like the previous example, it actually doesn't matter. You can choose any 2 points you want in order to make this work. Now, because you get to choose the points, you might want to keep the numbers low and choose numbers that are going to make things relatively easy. So in my case here, I'm going to call 0, 9. I'll call that 0.1, and 2, 13. I'll call that 0.2. So just like I did in the previous example, the first thing we're going to do is find our slope. So slope is delta y over delta x, or y2 minus y1 over x2 minus x1. So our y2 is 13 minus y1, which is 9, over x2, which is 2, minus x1, which is 0. So 13 minus 9 is 4, over 2 minus 0 is 2, and 4 divided by 2 is 2. So there we go. The slope of this line must be 2. Now let's go ahead and find our y-intercept. We can do that in the exact same way as we did before. So I know y equals 2x plus b. And now again, I can choose any point I want. I have 5 different points. I'm just going to pick one at random. I'll pick this first one and we can plug that in. So 5 is my y value, and that's equal to 2 times my x value, which is -2, plus b. So 5 is equal to -4 plus b. I'm going to have to add 4 to both sides. And we can see b is equal to 9. Now, in this case, there's actually even a better way to find that, because they gave me my y-coordinate right here. If you were to graph this, you can see that we'd have a point at 0, 9. So my line would look something like that. We'd have a positive slope of 2, so it's going up and to the right, and we can see the y-intercept is 0, 9. So in this case, they actually gave it to you in the table of values. So I actually didn't need to do this little bit of work. If I was smart about it and I looked at my table, I could have just seen that my b value is 9. If this point wasn't included, then we would have to do this extra little bit of work over here in order to solve for what the b value is. Either way, you're going to get the same answer, b equals 9. So again, let's answer the question. Therefore, y equals 2x plus 9. Okay, we're just going to do a couple more examples here, but I'm going to slowly ramp up the difficulty here. Here we have a point of 5, 9 and a y-intercept of -2. Okay, so well that means if I've given you the y-intercept, that's great. So I know b equals -2. So in this case, I really only need to figure out what my m value is. But how can I do that if I've only given you one point, 5, 9? Well, here's the secret, is I didn't just give you 1 point, I did give you 2 points. Remember, the y-intercept is a point. The y-intercept, by definition, is when x is equal to 0. So we could say, well, we have the point 0, -2. So we have the point 0, -2, and the point 5, 9. So with that in mind, we can do our slope. So I'll call this point 2 and this point 1. So y2 minus y1, watch your double negatives, so 9 minus -2 over x2 minus x1. So this is going to be 11 over 5. Now 11 over 5 is not a very clean number. I'm not even going to bother punching that into a decimal. I'm just going to leave it like that, 11 over 5. Like I've talked about in class, it's always much cleaner to leave your answers as a fraction. So therefore, I know y equals 11 over 5x plus b, which they gave us above, minus 2. Again, there is another way I could have gone about this. They gave us the y-intercept right at the beginning. So let's go back to the beginning and say, well, that means y equals mx minus 2. And what I could have done, in the same way I've been solving for b in the previous examples, I could solve for m. I could plug in the x and y value that they gave me. And I could say, well, 9 is equal to m times 5 minus 2. And now I could solve for my m this way. And if I do this right, I know what my slope is already, 11 over 5. So let's add 2 to both sides. So 11 is going to be equal to m times 5. Now I'll divide both sides by 5. And 11 over 5 is equal to m. So there's just a second way of finding the slope. And therefore, y equals 11 over 5x minus 2. Either one of these solutions would give you full marks. All right, how about this one? Again, I've given you a point, and then I've told you that we have this line, and it's going to have the same x-intercept as that line there. That doesn't even really look like a line I'm used to seeing. This is a line in what we call standard form. We'll talk more about that later on in the course, but it's still the equation of a line. So we have the same x-intercept as this line here, and our line also passes through this point. Okay, so we have a point. In order to get the slope, we need a second point. That's what they've given us here by saying the x-intercept. What does the x-intercept mean again? When you have an x-intercept, so for the x-intercept, I know that the y-coordinate is going to be equal to 0. On a graph, we're talking about, let's say this is my line, I'm talking about this point right here, where it crosses the x-axis. So, for the equation that they gave us, 2x minus 5y plus 6 equals 0, I know that the y-coordinate must be 0. So 2x minus 5 times 0 plus 6 equals 0. And now let's go ahead and solve for x. So 2x minus 0 plus 6 equals 0. So that means 2x is equal to negative 6, which means x, dividing both sides by 2, must be equal to negative 3. So that means we have a point at negative 3, 0. That's the x-intercept of that line, but it also passes through our line, the one we're concerned with. So now I have 2 points. I have a point here, and I have that point they gave us, 1, negative 2. Once we've established those 2 points, now it's exactly like our previous examples. We can find the slope by doing delta y over delta x. So negative 2 minus 0 over 1 minus negative 3. So this is negative 2 over 1 minus negative 3 is positive 4. So this is negative 1/2 or negative 0.5. Again, I prefer fractions, so let's leave it as a fraction. Now that we have our slope, we can solve for our y-intercept. We do that by looking at our general equation of the line. We can plug in our slope of negative 1/2, and then we can plug in a point. Again, it doesn't matter which point. We have 2 points. We have this point here, and we have the point negative 3, 0. Either one of them will work. I'm going to plug in the original point that they gave us. So the y value is negative 2, the x value is 1, plus b. So negative 2 is equal to negative 1/2 plus b. So I'm going to add 1/2 to both sides, so negative 2 plus 1/2 is equal to b. So negative 2 plus 1/2 is negative 1.5, or if we'd prefer, negative 3 over 2. So therefore, our equation of the line is negative 1/2 x minus 3 over 2. And there we have it. All right, let's look at one final example. This is kind of our word problem style of question, and see if we can piece this together. So in this particular example, we have the speed of sound in the air, and it can be calculated, and it's dependent upon the temperature of the air. So if the temperature of the air is 10 degrees Celsius, then the speed of sound is 337.4 meters per second. If the temperature goes up to 21.5 degrees Celsius, then the speed is 344.3 meters per second. So what I want you to tell me is, all right, well, what is the speed of sound if the temperature is up to 32.3 degrees Celsius? Well, what we're going to want to do is figure out what is the equation that's going to model this particular scenario. Now, what we have here is essentially 2 different points. I've given you temperature and speed, and I've given you temperature and speed again. So first thing we're going to do is let's declare what our variables are going to be. So we're going to say let y represent the speed, and x the temperature. Now, why did I choose that? Again, thinking about dependent, independent variables, y, the speed, is dependent upon x, the temperature. The speed depends on the temperature. So y must be the speed, x must be the temperature. So we have essentially 2 points. We have the points 10 and 337.4, and our second point is 21.5, 344.3. Once we realize what we have are 2 points, as we've done in previous examples, we can very easily find the equation of the line. We'll start by finding our slope. So y2 minus y1, 344.3 minus 337.4 over x2 minus x1, 21.5 minus 10. So this is going to be 6.9 over 11.5, which gives us 0.6 for our slope. Once we have that, our equation, y equals 0.6x plus b. Now we need to find b. We can do that by plugging in either equation, by plugging in either point. I'm going to go ahead and plug in point number 1 here. So 337.4 equals 0.6 times 10 plus b. So 337.4 is equal to 6 plus b. So therefore, my b value is 331.4. So I have an equation now. Y equals 0.6x plus 331.4. Now, why did I spend all the time doing that? Because now that I have an equation of the line, I can solve for any sort of follow-up question. And that's what they gave us up here. We've been asked to figure out, well, what is the speed, what is y, if the temperature is 32.6? So let me just get a little more space on my page here. So if the equation y equals 0.6x plus 331.4, they've given us the temperature, they've given us x. So y is 0.6 times 32.3 plus 331.4. So 32.3 times 0.6 and then add in that 331.4 gives us 350.78 meters per second. This is a word problem, so let's make sure we have our conclusion. So therefore, the speed is 350.78 meters per second when the temperature is 32.3 degrees Celsius. There we go. So that, ladies and gentlemen, is how you find the equation of a linear relation, the equation of a line, given any number of combinations of information. I want you to remember when you're doing this that ultimately you need to find two things, the slope and the y-intercept. As long as you keep that in mind, we can really solve for the equation given any combination of information. So as always, go online and check out the worksheet that's provided for you there. If you have any questions, please make sure you email your teacher and we'll try to help you out as best you can. And then we'll be moving on to Cycle 4 shortly. Good luck.